In section 7.2, we look at the ambiguous case of the law of sines. As discussed earlier in a previous section, we said that side-to-side angle was not one of the congruence axioms. In other words, if we know two sides and then an angle, or an angle and then two sides, we don't know for sure what the other two angles or what the other side would have to be. The ambiguous case actually could result in no triangles, so no possible triangle could be formed with the information that we are given. Could result in one exact triangle or two different triangles. So just because we are given a side and an angle does not necessarily mean that there's only one answer for the two remaining angles in the remaining side. So for example, let's say that we are given, or we are told, angle, let's say angle A, and then we are told side B, and we are told the length of side A. So let's say that we are given this information. So let's say that we're given information about angle A, side B, and side A. And what we are not given, what we would have to solve for, would be angles B, C, and then side C. So if we are told an angle and then two sides, in that order, and we do not know angle C, we do not know angle B, and what else did we say? We do not know side C, which would be here at the bottom of our triangle. You notice here that just because we are told what the length of side A has to be, does not necessarily guarantee that we know what angle C would have to be. So let's say that we know angle A, that's established, that has to be that particular angle, and we know that the length of B would have to be this. So this is the length of B. Well, the length of A is, here we see that the same in both cases here. If side or angle C swings in and makes a small angle, or if angle C swings out and makes a large angle, the length of A could still be the same in either case. So the length of side A, here we see in this little example, is exactly the same whether or not C swings in or if angle C swings out. So just because we know the length of A does not necessarily mean that we know what the angle C has to be. And in this example, we see that there are two possibilities for what could happen with angle C. And it doesn't matter if angle C swings in or swings out. The side C is something else we didn't know for sure. And so side C could be short or side C could be long to accommodate angle C swinging in or swinging out. So there's just some ambiguity here. We actually could form two totally different triangles. One here, where angle C could swing in and give a short side C. So there's one triangle, so triangle 1. Triangle 2, let's put that in light green here. Triangle 2 could be all of the givens kept the same, but then the unknowns could change, and we could end up with triangle 2 that looks something like this. So there's two possibilities based upon angle, side, side. So we call side, side angle, or angle, side, side. If we're given the information in this order, we have what we call the ambiguous case. And we're going to examine the possibility of having 0 triangles, 1 triangle, or maybe 2 triangles, based upon the information that we are given with side, side angle, or angle, side, side. In the next 3 examples, we will see a few situations arise. In the first example, we will see that based upon the information that we are given, no triangle could possibly be formed. And then in the next 2 examples, we will see the possibility of either 1 or 2 triangles. Sometimes we will only be able to form 1 triangle, and sometimes we will actually be able to form 2 totally separate triangles. We're going to see examples of this coming up soon. I'm not going to read through all of this here, but know that all of this is in your notes, and this is exactly what we're going to be doing in the next 3 examples. Here in example 1, we will see that no triangle will be possible. We are asked to solve triangle ABC if angle C is given to us as 75 degrees, 30 minutes. Side A is 17.9 centimeters and side C is 13.2 centimeters. So I recommend when you're on the test, in your homework, draw the triangle ABC first so we can see what, if any, congruence axiom that we might be working with. We have angle C. We're going to go ahead and label that. We know side A. Go ahead and label that. And then we know side C. Go ahead and label that as well. So let's see what we know. We know a side, and we know the next thing we know is a side, and then the next thing that we know is an angle. So this is side-side angle. And we want to draw the triangle first so we can see that we are dealing with something that is not a congruence axiom. So this would be the case where we have to consider that there could be no triangle, there could be one, or there could be two. So notice that in this example we are only given one of the angles, so we cannot easily determine the other two. We will actually have to use the law of sines to determine the other two angles, and also the remaining side B. Okay, so we're going to set up our equation using the law of sines. We want to be careful to remember that when we are setting up our equations, that one of the fractions has to have all of the knowns filled out, and the other fraction has to have only one unknown. So when we're setting up our fractions, we notice that we know side C and we know angle C. And this is the only letter that we actually know everything about. So when we set up our law of sines, since we're solving for angles, we're going to solve for angle A and angle B. If we're solving for an angle, we're going to put the angle on top. So we're going to do sine of angle C divided by side C. And we're going to set that equal to either B or A. So whichever one we're going to solve for. Well, you notice we don't know anything about B at all. We don't know angle B, we don't know side B. So that's two unknowns in the same fraction. Well, we don't want that. So we're going to solve first for angle A, because we know side A. So when we actually fill out information, we have sine of angle C divided by side C, sine of angle A, and that's what we don't know A, divided by side A, which is 17.9. So we are going to solve for A because we know side A, at least side A, so we only have one unknown in this entire equation. Now we're going to solve, we want to get sine A by itself. Our ultimate goal is to figure out what angle A has to be in order to make this statement true. We're going to go ahead and multiply both sides by 17.9. And now we have sine A by itself. And we're going to put this into the calculator, and keep in mind that we need to convert to decimal degrees, and I'm going to write this as sine, or 17.9 times sine of 75 plus 30 divided by 60 minutes. All of this divided by 13.2. And what I recommend here, since we're solving for the angle this time, what I recommend that we do is we figure out what is that ratio going to be. Let's figure out what this value is first, because we're going to have to put this into our inverse sine function in order to solve for the angle. So when we put this into our calculator, we get 1.312866876. So what this is saying here in this equation is that the sine value of angle A would have to be 1.3 and so on. Well, what do we know about sine? Well, we know that the range of sine, the output values for sine, are actually only allowed to go from -1 to 1. So this is actually out of the range for what the possible sine values of any angle could be. So when we put this into our calculator, we should expect that the calculator is going to tell us that this is not possible. So we're going to let our calculator take care of this for us. Sine inverse, so hit your sine inverse button on your calculator. We're going to put this sine value into the sine inverse function, and it's going to spit out angle A for us. And as expected, what the calculator would tell us is that we have a domain error. In other words, sine inverse is not allowed to be evaluated at that sine value because that sine value is not possible. So if there's no angle A that's possible, which is what we've just decided, there's no possible angle A that could actually work to form this triangle. If there is no such angle A, then there is no possible triangle that would work with these given dimensions. So we see here that the side-side angle or angle side-side case has led us to the possibility here where we have no possible triangle that could be formed with that information that we were originally given. Here in this example, we're going to see that there are a possibility of one or two triangles here, and we are asked to solve triangle ABC if we know angle A, side A, and side B. So I always suggest that we make a little picture of our triangle. Not that it's to scale, and not that this is the only possibility, but just to give us an idea of what, if possible, congruence axiom that we're working with. So let's label our sides. We have 61.4 degrees for angle A. For side A, 35.5 centimeters. For side B, 39.2 centimeters. So we see that we know an angle, we know a side, and then we know a side. So this is ASS, which is not a congruence axiom, which means that we have the possibility of having no triangle, two triangles, or only one triangle. So now we have to consider what we call the ambiguous case. And remember that ambiguous means that it's not just one possibility, there's actually several possibilities that we could encounter for the remaining parts. So angle B, angle C, and then we also want to find side C. So we have three parts that we're going to solve for. Now, notice that in the ambiguous case, there are two angles that we do not know. And we want to solve using the law of sines. So if we're going to solve using the law of sines, we must have one of our fractions with everything in it known. So we see here that we don't know anything about C at all. So angle C or side C. So we're not going to use that as one of our fractions. We're going to use fraction with the A's and the B's. And we don't know angle B. So we're going to put the angles on top. I'm going to say sine of angle A divided by side A. And we're going to set that equal to sine of angle B, which we do not know, as our one unknown in our equation, divided by side B. And we're going to multiply both sides by 39.2. That way it cancels out here, and we're left with sine of angle B, and is equal to, let's say, 39.2 times sine of 61.4 degrees divided by 35.5. And I suggest that when you are working with the ambiguous case that you type this into the calculator first to figure out what the sine value is that we're talking about. And when I put this fraction into my calculator, I get 0.96949106. And what this tells me is that this is going to be possible because sine values are between -1 and +1, and this is within the allowed range for sine. So we'll definitely be able to find one angle that will fit this possibility. So let's put into our calculator sine inverse of this value, and then it should tell us what angle B is. And remember that the inverse function for sine will spit out angles from quadrants 1 and potentially quadrant 4. Since the sine value is positive, we know that it'll spit out an angle from quadrant 1. So the quadrant 1 angle that we get is 75.8. We're going to go ahead and round to the nearest tenth. So I'm going to go ahead and just put the 10th degree there. So 75.8 degrees. Now we want to be careful, and this is where the ambiguity arises. In other words, this is where we have the possibility of maybe one answer or two answers coming out. The quadrant 1 angle is 75.8 degrees. Now, sine is positive in quadrant 1 and also in quadrant 2. So we could be actually describing two different angles. And the quadrant 2 angle, having that same positive sine value, would have a reference angle of 75.8 degrees. So the quadrant 2 angle that we want to describe would be equal to, we'll have 180 degrees minus the reference angle. And we get that we have a possible quadrant 2 angle of about 104.2 degrees. Now both of these are possible angles for angle B. These are possible values for angle B. We want to consider both possibilities here. So we want to consider the case that we might have two triangles, triangle 1 and what we would call triangle 2. And triangle 1 would come from angle B coming from quadrant 1. And for triangle 1, we want to know all three parts. We want to know all three angles and all three sides for what we would call triangle 1. Now in triangle 1, angle A was given to us, 61.4 degrees, and that's actually going to be true for both of these triangles. This is triangle 2. So angle A was given. Angle B for triangle 1, we're going to consider that to be that quadrant 1 angle that we got, 75.8 degrees. What else were we given for sure? Side A, there's no ambiguity there. That was given to us as 35.5 centimeters, and that's going to be true for both. Let's go ahead and label both of those. So here's everything we know for sure, no ambiguity here. And side B also for both, we know has to be 39.2 centimeters. Now for the second triangle, one of the options was the quadrant 2 angle that had that sine value 104.2 degrees. So angle A, side A, and side B were all given. So we know those for sure for both triangles. Now the ambiguity arises with that quadrant 1 angle and quadrant 2 angle possibilities for angle B. So we have both of these possibilities. Now if we know, let's look in triangle 1, if we know angle A and we know quadrant 1 angle for angle B. If we know angle A and angle B, then we know angle C. So we're going to find angle C by subtracting from 180 degrees. So 180 degrees, take away 61.4, take away 75.8 degrees. And what angle do we get? See, I get 42.8 degrees would have to be what angle C is in the first triangle. So if angle B is 75.8, then angle C would have to be 72.8 degrees. In triangle 2, we were given that A was 61.4 degrees. We consider the possibility that angle B could have been that quadrant 2 angle, 104.2 degrees. Now, in triangle 2, if that is angle A and that is angle B, then what would have to be angle C? Well, it has to be whatever's left over from 180 degrees. So we're going to take 108 degrees, subtract angle A, subtract angle B, and what we have left over that's possible for angle C would be 14.4 degrees. So the last thing we have to know is for these two separate triangles, if we look in triangle 1, what would have to be the value of side C? And if we look in triangle 2, what would have to be the length of the value of side C? So we have two different triangles that we're actually forming, so the lengths of side C will be different for each one. And we're going to use the law of sines in both cases to solve. Alright, now within triangle 1, let's find the length of side C using the law of sines. So we're going to take our fraction that has the c's in it, so side C divided by angle C, which in this triangle would have to be 42.8 degrees. And we're going to use the original two knowns within that fraction. So we were originally told both angle A and both side A, so we are going to use side A, 35.5 centimeters. Well, we don't need the centimeter part. And sine of angle A, which is 61.4 degrees. Okay, we're going to multiply both sides by sine of 42.8 degrees. And that way we can solve for side C. These will cancel and we're left with C is equal to. And we're going to put all of this into our calculator. So 35.5 times sine of 42.8 degrees divided by sine of 61.4 degrees. And we're going to solve for side C here, and we are going to, let's round to the nearest tenth. So I get 27, and rounding to the nearest tenth I get about 5. So 27.5 centimeters for side C within triangle 1. Now in triangle 2, we have a different scenario. We're going to solve for side C, and this time we're going to put side C divided by angle C. Now within triangle 2, angle C is 14.4 degrees, equals, and we're going to use the two unknowns that we were given originally, angle A and side A. So once again, we're going to do 35.5 divided by sine of angle A, 61.4 degrees. We're going to multiply both sides by sine of 14.4 degrees. And that way it cancels from this side. We're left with C is equal to. And we're going to put all of this into our calculator. 35.5 times sine of 14.4 degrees divided by sine of 61.4 degrees. So within triangle 2, I round to the nearest tenth, I get 0.1. So side C in triangle 2 would be 10.1 centimeters. So we see in this case, we actually have two possible triangles, two totally different triangles that could be formed with the original information that we were given. Here in example 3, we once again will consider the possibility of having either one or two triangles. And we are asked to solve the triangle ABC if we are given B, angle B, side B, and side A. So we're going to draw a quick little sketch of our triangle. Label the knowns. And we want to see what congruence axiom, if any, that we are working with. Well, it looks like we're given an angle, and the next thing we see going around is a side. We don't know angle C, so we know another side. So we know angle, and then a side, and then a side. So this is the ambiguous case, meaning that it is possible that we could have several solutions for angle A, angle C, and side C. So there are a couple of options. Maybe we can form no triangle with the information we're given, maybe with just one, or possibly two. So we have to consider the ambiguous case. Now notice in this case also we only know one angle, so it is not possible to easily solve for the other two angles. We will have to use our law of sines to solve for one of those angles first. Now we notice that we know everything about B. So we know angle B and side B. So we're going to set up one of our fractions using B. So sine of angle B divided by sine B. So we know everything within that fraction. And we want to set this equal to the fraction where we know at least one of the letters, parts of the letter, but we don't know the other one. So we don't know anything about C at all. We don't know side C, we don't know angle C, so we will not use the fraction with C's. We will use the fraction that has the A's. And so we're going to have the angle on top, so sine of angle A, which we do not know, divided by side A, which is 19.6. So once again, we do not know what angle A is, so we're going to have to solve. We're going to multiply both sides by 19.6. That way these cancel out. And we're left with equals sine A on this on the right-hand side, and we're going to put this into our calculator and figure out what this value would have to be. Now once again, I recommend that you actually figure that out before you type it into the inverse function. So 0.718942837. So we see that we have a positive sine value, and this is a possible sine value for an angle. So our calculator should give us an answer. We're going to hit sine inverse, and we're going to feed that sine value into the inverse function. And our calculator should give us a possible angle for angle A. And remember that the calculator will tell us the quadrant 1 angle. So quadrant 1 angle would be, we're going to round to the nearest tenth again, and I get 45.96, which when I round to the nearest tenth, I get 46.0. Now we said keep in mind that sine values are positive in quadrant 1 and also in quadrant 2. So if we are given the quadrant 1 angle of 46.0 degrees, then we want to consider the quadrant 2 angle that has that same reference angle. So the quadrant 2 angle would have to be 180 degrees minus that reference angle 46.0. So we get a quadrant 2 angle of 134.0 degrees. So we want to consider the possibility of having these two separate triangles with an angle from quadrant 1 and from quadrant 2 for angle A. So let's set up our two possible triangles and see what will happen here. So triangle 1, triangle 2, and we're going to write out everything that we are given and what we need to solve for. Okay, so let's first establish what we were given for both triangles at the very beginning. Angle B must be 68.7 degrees. That's what we were given originally for angle B, and that's not going to change in either triangle. Also, side B was 25.4 inches, and that's not going to change. And side A, 19.6 inches. These are the three original values that we were given. So what we're going to solve for is potentially angle A, angle C, and side C for triangle 1, and the same thing for triangle 2. Okay, so our quadrant 1 angle we said was 46.0 degrees, and our quadrant 2 angle for A was 134.0 degrees. So let's solve for angle C in both cases. So we're going to do 180 degrees, subtract 46, subtract 68.7. And I get that angle C would have to be 65.3 degrees. And that is possible. So we have one possible triangle. But what about in triangle 2? Well, in triangle 2, if you take 180 degrees and you subtract 134 and you subtract 68.7 degrees, we will have nothing left over for angle C. So if I take 134 plus 68.7 degrees, we see that that combined value is already greater than 180 degrees. And if I have to sum all three angles to get exactly 180, we automatically have a problem. There's nothing left over. Angle C would have to be negative, and that's not possible. So we are going to say that it is not possible to actually form two triangles because the required value for angle C would have to be negative. So we will only be able to form actually one triangle. So there's only one possible triangle that could come from the given information. The last part that we need to know is what is side C. So we'll set up our fraction with side C divided by sine of angle C equals. And let's use the letters that we were given everything for. So we were told angle B and side B, so we'll use letter B. We'll use the B fraction. 25.4 for side B divided by sine of angle B. And we're going to solve for C by multiplying both sides by sine of 65.3 degrees. And we get C is equal to, we're going to put this into our calculator, and we're going to round to the nearest tenth. So I get that C is approximately 24.8 inches. Now we know everything that we have to know for triangle 1.